When I was young, I used to secretly sneak biscuits from the cookie jar, and I was really worried about what clues I was leaving behind and whether my mum would actually be able to find me out based on that evidence. My name is Melanie Bailey, and I actually gave up crime and I became a physicist. But I'm still absolutely fascinated by the way that science can be used to link traces of evidence to a particular crime. And so now I've devised a completely new way to help catch the bad guys. I've developed a new technique for forensic analysis of gunshot residue. Even CSI doesn't know about this yet. My samples are usually provided by the police from shooting incidents and the local firing range. Now, gunshot residue are tiny particles that are ejected from a gun when you fire it. And these particles are spherical and they're metallic, and they tend to get deposited all over your hands, on your skin and on your clothing. And they're actually very difficult to wash off. They can persist on your clothes for several days after shooting. When I've collected my samples, I put them into my machine, an ion beam accelerator, and this generates a beam of charged particles of either hydrogen or helium and accelerates them to speeds of around 10% of the speed of light and fires them at my forensic samples. So I put the residues in the machine and I switch on the ion beam. And when the beam hits the samples, X-rays or gamma rays are emitted. And each element within the particle has a specific X-ray or gamma ray associated with it. And so I can tell exactly what's in the sample and how much of it there is. We've got lead.
Okay, so let's see what we've got. Lead. So let's try and work out what some of these other peaks are.
Well, that looks like it could be copper. Is it copper?
I think we're looking at copper. Yeah, it looks like zinc in there too.
Yeah.
Okay, zinc.
Okay.
Yeah.
Good.
And that's probably iron. That's good.
Yeah. So we're already seeing a lot of new elements that haven't been seen before.
Yeah, they wouldn't be. Yeah. These haven't been seen before, which is really good.
What about the gammas?
Okay. Wow. Okay. So this one at 440 here is definitely sodium.
Yep.
Oh, we haven't seen sodium in these before.
So that's quite surprising, actually. It's not what we expected, is it?
It's not what we expected. No.
When I'm in the lab and I'm doing an experiment, sometimes I'm the first person in the world to know what's actually happened at that scene of a crime, and that's really fascinating. Well, when the police make an arrest of a suspect, they'll look for gunshot residues using a machine called an electron microscope. Now, the problem with the electron microscope is that it's much less sensitive than my technique, the ion beam. And so they can see certain elements, but we can see extra elements that they don't see. The significance of this is that different manufacturers of ammunition powder use different recipes. And so ammunition powder from one source will contain different elements to that of another source. Now, with the ion beam, we can pick up differences between these different ammunition powders that you can't see using the police techniques. There's another problem that my technique can solve, and this is the problem of contamination. And this can happen when gunshot residue particles are on the police officer that makes the arrest in the first place, or perhaps they can be picked up when the suspect is being transported in the police car. Now, using electron microscopy, it can be very difficult to detect contamination because you have very limited information. But using the ion beam, you have much more information about particles and the sources that they've actually come from. I hope that this information can be used to strengthen the value of gunshot residue evidence in the courts. This isn't all I can do with the accelerator. It's not just gunshot residue. I can also look at textile fibres to see how fibres from different types of clothes vary from suspect to suspect. I'm also looking at what I can learn from fingerprints, and I've found that we can actually pick up molecules from specific brands of different hair gels and different soaps, for example. So what I want you to do is use your index finger and rub it down your nose and then down your left cheek and your right cheek. Awesome. Rub the fingertips together. Wonderful. So that just means that we've got all the sweats from the face incorporated with the sweats from their hands as well, which is representative of what somebody would actually have in their sweats if they were going to commit a crime. And something that's really interesting that I'm investigating at the moment is whether we can tell whether somebody's a smoker or a drug user from the chemical composition of their fingerprints. It's fantastic to be able to use physics to help the police to solve crimes that they couldn't previously solve. So looking back, physics actually gives me more of a buzz than cake-related crime ever did.